Alright, starting the final review, problem number 1. First thing we have to do here is figure out the coordinates of each point. Here I have 1, 1. Here I have 5, 2. Here I have 3, 5. Okay, now since it's a 90-degree rotation, you could look at your rules, and here's the rule for a 90-degree rotation. Alright, there it is. So all we have to do is switch the values and change the value of the x to negative. Alright, so I'm going to have a prime. It's going to be 1, 1. The x value becomes negative. I have b prime. It's going to be 2, 5. The x value becomes negative. And c is going to be 5, 3. And the x value becomes negative. Alright, now I'm going to plot these points. Negative 1, up 1. That's my a prime. And then I have negative 2, up 5. That's my b prime. And then I have negative 5, up 3. That's my c prime. Alright, there's our 90-degree rotation. Next problem. Alright, find and sketch the image. Triangle ABC under a rotation of 180 degrees. Alright, so same thing as before. I have to figure out the coordinates for each point. This is 2, negative 1. This one here is 5, 0. And B is 4, 3. Okay. So for a 180-degree rotation, here's the rule, as seen on your yellow sheet. Okay. Alright, so what do? I just change the values for x and y to negative. Alright, so my a prime is going to become negative 2, positive 1. My b prime is going to become negative 4, negative 3, and my c prime is going to become negative 5, 0. Okay, so I have negative 2 up 1. Alright, then I have negative 4 down 3. Alright, left 4, down 3. There's my b prime. And then I have negative 5, 0. Okay, and that's all there is to it. Let's go on to the next problem. All right, in the diagram, list all pairs of vertical angles. Okay, so here we have a pair. So angle 1 and angle 4. Then we have 2 and 3, angle 2 and angle 3. Then we have 5 and 8. Angle 5 and angle 8. And then we have angle 6 and angle 7. Done. Alright, in the diagram, list all pairs of vertical angles. Okay, here we have vertical angles once again. Angle 1 and angle 3. Then we have 2 and 4. Then we have 5 and 7. Then we have 6 and 8. Done. All right, for 5, a triangle ABC is defined by its vertices. All right. This triangle is then reflected in the x-axis. What are the coordinates of its image? A prime, B prime, C prime. Okay, so if you're going to do a reflection, all right, over the x-axis, here's the rule. This is what happens to your points. The y value becomes negative. All right, so my A prime is going to be 1, negative 3. And then my B prime will be negative 2, negative 5. And my C prime will be 0, 4. All right, that's all there is to it. We're done. You just have to know how to apply the properties. Alright, so we have a point A that they give us under the glide reflection that involves a translation. Okay, so translation, I'm going down, I'm going left 1, and then I'm going down 3. Alright, so there's my new A. Alright. And then I have a line y equals 3. This is my line here, y equals 3. All right, passes to the y value here of 3. I'm going to reflect the point over that line, so it's a distance of 1 away from the line, so it's 1 unit on the other side away. And this is my A prime. And they want us to give its coordinates. The coordinates for A prime is 3, 2. All right, done. All right, in the diagram, what is the image of point A under the glide reflection? That involves a translation. All right, so we're moving back 3 and up 1. Okay, that's my new A, I guess you could call that, because they want us to call the point we end up with A prime. All right, and reflect in the line x equals 1. Okay, here's the line x equals 1. Let's see, we are 5 units away, so I have to be 5 units away on the other side. All right, there's my new point, A prime. And the coordinates for A prime are, let's see here, we're over 6, and we're going to go up 5. All right, done. All right, for number 8, state whether the following pairs of triangles are necessarily congruent. If congruent, state the congruence postulate. Okay, well, I have one pair of sides congruent. I have a second pair of sides congruent. Any other information I could extract between the two triangles? Yes, they have these vertical angles in common. All right, so I could use the shortcut SAS, SAS. So yes, any reason, SAS as your shortcut. Next problem. Okay, let's see here. Are these two triangles congruent? Well, they share one pair of sides in common. They share another pair of sides in common. Anything else? Well, they share this one side right here. You're just going to draw 3 tick marks because they both share that segment in common. So that's your third side. So the triangles now are congruent by S, 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 S. Done. In the sketch using the indicated characteristics, can the two triangles be shown congruent? Why or why not? Okay, well, they give us these arrowheads here. That's really important. All right, first thing, I have these sides in common. That's one pair of sides in common. All right, and there's different ways to go about doing this problem. I'll show you 2 different ways. I know these sides here are parallel with the arrowheads, so I could say that these are alternate interior angles. They're congruent. I could also say that these angles are alternate interior angles, and they're congruent. So I could say yes, in this case with this information by AAS, or I could have just as well have done this. Use that side, use these alternate interior angles, and also say that, well, these are vertical angles here. So I could also say yes by ASA. So both will be correct answers. All right, for 11, in the sketch using the indicated characteristics, can two overlapping triangles be shown to be congruent? Why or why not? All right, this is a little tricky because they're overlapping. All right, but here I have this triangle. All right, and then I have this blue triangle. All right, now they share this side in common, which is the leg. All right, they're both right triangles. And let's see. Now, these tick marks are only telling you information regarding these side lengths, not the hypotenuse. All right, so you can't say the hypotenuses are congruent because we're just looking at part of the hypotenuse here. But I have an isosceles triangle here. So I can say that these angles are congruent. All right, so what I have then, looking at the red triangle, I have AS. And looking at the blue triangle, I have AS. All right, so it's not HL in this case. It's AAS. All right, that's all there is to it. Let's go on to the next problem. All right, suppose triangle ABC is congruent to triangle EFG. For each of the following, name the corresponding parts. Okay, since they set up the problem this way, the order of the letters matters. Okay, so angle A corresponds to what angle for the other triangle? Angle E. And BCA is the same as FGE. And segment AC is congruent to segment EG. All right, that's all there is to that. Let's do another problem. Same type of problem. All right, the order of the letters matters. Okay, so I have angle B is congruent to angle F. All right, then I have CBA. CBA is congruent to GFE. Then I have AB. AB, that's congruent to EF. Alrighty, let's go on to the next problem. For the following problems, complete the triangle congruence statement and name the postulate that justifies the statement. Okay, so let's see the information that they give me here. They're telling me that it's isosceles with legs RT and TS. Alright, so I know these sides are congruent. Q is the midpoint of RS. I know this is true then. All right, and they share TQ in common. So I know the two triangles are congruent by SSS. Now let's make sure that we get the order of the letters right. R, okay, that's going to correspond to S. And then I have T up here. So I should go with T again. And I go with Q. All right, done with that one. Next problem. Okay, y is the midpoint of XZ. Y is the midpoint of XZ. Okay, so I know that these segments are congruent. AY is congruent to BY. AY is congruent to BY. Oops, let's take that away. BY. Okay, and AYX is congruent to BYZ. BYZ. Okay, now I know these triangles are congruent by what? SAS. SAS. All right, now let's make sure that the triangle that we state here, all right, the points are ordered correctly. So if x corresponds to what? X should correspond to z, and then I have y, and then in this case I go back to a. All right, a corresponds to b. All right, done. For 16, SA is the angle bisector of TSM. TSM. All right, angle bisector. And ST is congruent to SM. ST is congruent to SM. All right, I have that much. All right, and now I know they both share this side in common. That's reflexive property right there. All right, so I have S, A, S. All right, now the triangles are congruent, and I want to make sure to order the points for the second triangle correctly. S, well, that corresponds to S, and then I have A, corresponds to A, and then T corresponds to M. All right, done with that one. All right, for the next one, P is congruent to N. All right, and M is the midpoint of PN. M is the midpoint of PN. All right, so I know those are congruent. And, all right, that's all they give me. I know these are vertical angles here, so they're congruent. So I could say the triangles are congruent by ASA. All right, now let's make sure to order the points for the second triangle correctly. P corresponds to N. Then I have M in the middle. Yeah, M stays in the middle. And then I have K corresponds to Q. All right, going on to the next problem. All right, in the diagram, AY is parallel to BZ. AY is parallel to BZ. Okay, Y is the midpoint of XZ. All right, it's the midpoint. All right, and AY is congruent to BZ. AY is congruent to BZ. All right, can it be shown that angle A is congruent to angle B? Explain. Angle A is congruent to angle B. Okay. All right, well, all right, those are my parallel sides. So these angles here are congruent because those are corresponding angles. Okay, so it says to explain. It doesn't really say to state it as a proof, but we're going to do that anyways. So let's just show it as a proof. That's your statement. That's your reason. They tell me AY is parallel to BZ. That's given. All right, 2, they tell me Y is the midpoint of XC. Okay, and that's just definition of midpoint. Oh, sorry, that's given. Given. All right, and they say AY is congruent to BZ. That's given. All right, I know XY is congruent to YZ. That's definition of midpoint. All right, and now I could say that angle AYX is congruent to angle BZY. And that's just, or those are corresponding angles. Okay, so now 6, I can say that triangle AYX is congruent to triangle BZY by what shortcut? SAS. All right, and now the last part, I can say that angle A is congruent to angle B. Why? Well, you know the two triangles are congruent, so I know all corresponding angles and sides are congruent. So my reason is CPC/TC. All right, we're done with that. All right, for the next one, in the diagram, triangle HMK is an isosceles triangle. HMK is an isosceles triangle with base KM. Base KM. All right, so these are the legs of the isosceles triangle. All right, it says GJ is parallel to KM. Okay, so put a little arrowhead here to show that they're parallel. All right, and H is the midpoint of GJ. H is the midpoint. All right, so I know these segments are congruent. It follows that. Okay. Okay, wow. All right. Takes a little thought to extract valuable pieces of information out of this. All right, I want to show that KHG is congruent to MHJ. Okay, that's an M here. Triangle. All right, now how do I know those are congruent? Well, check this out. I know since I have an isosceles triangle here, I know these are congruent. All right, since I have two parallel sides here, I know that these are congruent. Okay, because they're alternate interior angles. And these are congruent because they're alternate interior angles. Okay, so notice that I'm using one arc for all these angles, which shows that they're all congruent. So now I know the triangles are congruent by SAS. All right, SAS. SAS. All right, then here it says angle G is congruent to angle what? J by reason. CPC/TC. There we go. On to the next problem. All right, they're telling you AB is parallel to CD. AB is parallel to CD. All right, PB is congruent to CR. PB is congruent to CR. All right, and PS is parallel to QR. PS is parallel to QR, okay? Got a lot of parallel stuff going on here. All right, triangle PAB. Triangle PAB, all right, this triangle is congruent to this triangle. Okay. There's a lot going on here. Well, right away, since I have parallel lines here, I know that these angles here are alternate interior. They're congruent. Okay. All right, check this out. This may be a little hard to see initially. I have these two parallel lines here, right? This is a transversal. So these angles here are alternate exterior. All right, they're congruent. So I can say the triangles are congruent by ASA. There's a possibility that you may be able to extract other information, but that's what I saw. All right, so I know triangle PAB is congruent to triangle R, and it's going to be DC. All right, so that's all there is to it. If you have any questions about any of these problems, if you need any clarification, make sure to ask for help. That's the first 20.